Okay, here we are again. Welcome back. We're going to determine LS. That value if the angle is 89. So theta is going to equal 89.999 degrees. All right? Yes? Okay, now we know that value here, half that line, is 2 meters. Otherwise you couldn't really do it. So we have a 4-meter cord, a 4-meter clothesline. We have something hanging, we have a 50-Newton load hanging from that, and we want to know how much that's going to actually sag. If the load is 50 newtons and the angle it makes, it sags so little that the angle is actually 89.999. Is that right? Okay. So what we say is this. Let's write it out. We know that we have LS and we have that, right? So it's going to be opposite over adjacent. Would you agree? Opposite over adjacent. So it would be tangent theta equals opposite over adjacent. Would you agree?
Yes.
Okay, excellent. And that would, so then what you would say is tangent theta, tangent of 89.999 degrees equals opposite 2 meters over LS. Would you agree?
Yes.
Is that on the screen?
Yeah.
Excellent.
Yeah, it's right there.
Okay, now, so what we're going to say is we're going to get rid of this now. We're going to get rid of this here. Okay? We're going to get rid of this. And we're going to rewrite this. And we're going to say LS equals 2 meters over tangent 89.999. LS, now we can erase this, right, Mom?
Yes.
Okay, we can erase that. And LS is going to be equal to what?
0.0000049. 0.09.
0. How many zeros?
4.
How many?
4.
4 zeros. Okay, go ahead.
49.
Is that right?
Yes.
Meters?
Meters.
All right.
Wait, change
right?
that 0 right there in front of the 4 to a 3.
Change this to a 3?
Yeah.
Okay. That's a 3.
There we go.
All right, is that cool? Are you all right with that? Yes? Yes?
Add one more 0. I'm sorry.
No, that's
Yeah.
okay.
Yeah,
That's okay. That's all right. We're here to double check each other. Okay, so 2 divided by tangent 89.123 close parentheses equals 3.49 times 10 to the negative 5th, right? So 1, 2, 3, 4. So we need an extra 0, right?
Yes.
You were correct. So, is that right now?
Yeah, that's...
1, 2, 3, 4, 5. No, that's not right. It's going to be 1, 2, 3, 4, 5. That's right. Okay? Right? Now, let's do this. It's meters, right? Correct?
Yes.
That's meters? Okay. Divide that number. That's meters. Divide that by 1,000. Right? What do you get? Divide that number by 1,000. And you're going to get .0.
I just had 3 zeros.
349 millimeters. Is that right?
Well, I got 3.49 times 10 to the negative 8.
No.
No.
You're dividing by 1,000. I'm sorry, my apologies. You're multiplying by 1,000.
Okay.
I'm sorry. You were absolutely right. Multiply by 1,000. I'm sorry. Multiply by 1,000. You're going to multiply that by 1,000, and you're going to get .0349 millimeters.
Okay.
Is that right?
Yep.
Okay. So that's going to be 3/100ths of a millimeter. Okay, 3/100ths of a millimeter. Right? Do you see the small line there? Do you see the small line? Is that coming up? You see the small lines?
Where your finger is?
No, where the
yeah, it's coming up. Yeah.
All right. That is going to be 0.03, 3/100ths of one of those. That's how much it's going to dip, which is unbelievable. Oh, we have a coffee delivery. Excellent. We have a Oh, you're a wonderful person. I'll get you later. Is it okay? We're filming. That's okay. Thank you, Matthew. You're a wonderful person. I don't care what anybody says about you. Okay, now, so I had a coffee delivery. Oh, what a brilliant person. Okay, now, so that's it. That's really what I want to do. So this number really doesn't tell you much, does it? I mean, it's a small number, right? But when I say that it's 3/100ths of a millimeter, it's actually 3.5 hundredths of a millimeter. Unbelievable. So that would have to be really, really taut for that to happen, correct? But if it did happen, you'd have over 1 million newtons of force there. Over 1 million newtons of force. All right? We're done. Clothesline physics.